Welcome to the Prosthetics and Orthotics Podcast with Joris Peels and Brent Wright, where we explore the latest developments and advancements in using 3D printing technology to create custom prostheses and orthoses. From in-depth interviews with leading industry experts, to case studies, to patient experiences, we delve into the exciting and innovative world of 3D printing and its role in the field of prosthetics and orthotics. Join us as we journey into the future of personalized healthcare with 3D printing.
Hi everyone, my name's Joris Peels and this is the Prosthetics and Orthotics Podcast with Brent Wright. How you doing, Brent?
Hey Joris, yeah, good to be on. I'm doing well, and I caught COVID right before Christmas.
Oh goodness. Are you doing a little better?
I am. You'll probably hear a little scratchiness in my voice, but I feel 100% way better than I did last week. So this is great.
Imagine. I can imagine. All right.
And I hear you've never had it. So wow, that's kind of crazy.
I'm going for the last one. I want to be the last one on Earth to not have it. But okay, I hope you're doing all right, dude. I hope you're doing okay. Yep. So who's on the show, man?
Oh man, I'm really excited about this. I had reached out to Dr. Aadeel Akhtar, and just to see if he would share a little bit of his story and his journey on PSYONIC. And as I started looking into what he has done and really the journey that he's on, and almost just beginning this new journey, I couldn't wait to hear what he had to say, not only about their product, the Ability Hand, but the kind of where they see things go next. And what I found quite interesting is one of his first trips was in 2014 to Ecuador, Quito, Ecuador, to be specific. And it looked like he was with Range of Motion Project. He can clarify that. But I grew up in a small town called Pifo, right outside of Quito, Ecuador. And so I really thought that was interesting. So super excited to have Aadeel on the show today.
Yeah, thanks, Olga. Aadeel. So thanks for being here today. So how'd you end up getting into MP?
Yeah, thanks for having me on the show, guys. I'm really excited to be here. And I got into the field of O&P. This is actually something I've wanted to do my entire life, was to work on bionic limbs in particular and prosthetics. And it actually started for me when I was 7 years old. My parents are from Pakistan. I was born in the Chicago suburbs, but I was visiting Pakistan. And that was the first time that I'd met someone with a limb difference. And she was my age, missing her right leg, using a tree branch as a crutch, living in poverty. And that's kind of what inspired me to go into the field. And so I went to Loyola University Chicago for undergrad, got a bachelor's in biology. The original plan was to become an MD. I think the original plan was to become a neurosurgeon, working on connecting, bionic limbs to people with limb differences. And then my sophomore year of undergrad, I took my first computer science class and I absolutely loved it. I loved everything about coding and engineering. And I realized that if I became a straight up doctor, I wouldn't get to do any of the cool stuff that I was learning in my computer science and engineering classes. So I wanted to find a way to kind of merge the two. And this was around, 2007, 2008, that right down the street in downtown Chicago at what was formerly known as the Rehabilitation Institute of Chicago, and it's now the Shirley Ryan Ability Lab. They had just done the first clinical trials on targeted muscle reinnervation, where they were rerouting the nerves so that you could control prostheses better for amputations. And they were using, the DARPA Luke arm at the time. And they had patients that were controlling these devices just like intuitively, right? Just by using their neural control to bend their phantom elbow and make a phantom fist. And this was this perfect combination of like engineering, clinical medicine, like physical medicine, rehabilitation, neurology, computer engineering, electrical engineering, mechanical engineering. And this was exactly what I wanted to do. Now, the problem is that, these devices cost like hundreds of thousands of dollars to make, especially the ones that were sponsored by DARPA. And, I wanted to build these prosthetic devices that were more accessible to others. And we can get back to that later. But I ended up getting a master's in computer science at Loyola University Chicago, a bachelor's in biology. I taught there for a couple of years. Then I went to the University of Illinois at Urbana-Champaign, got another master's in computer engineering, and then a PhD in neuroscience. And then I left medical school to run the company full time because it was a bit more fun to build bionic limbs than to finish medical school, I guess.
Okay. So if we're talking about like a bionic limb, I mean, it sounds very kind of $6 million man-ish, let's say, if you're that old. So what does it actually mean if we're looking at it, or is it used incorrectly all the time, or is it just what does it actually mean?
Yeah, so the way that we use bionic in particular is that, I mean, a lot of people will think myoelectric, for example, so muscle powered prostheses. But for us, it's not just that it's powered by your muscles, but we're agnostic to the control system. So we have a lot of research collaborations that we're doing with direct brain implants, with direct nerve implants. So it's being able to control these electronic devices with higher levels of biointegration in particular.
Okay, and so far, and so the effort that you're specifically focused on, right? Well, tell us a little bit about how you ended up with at Psionics, right? Because that must have been quite a journey before that as well, right?
Yeah, and the original plan was never to start a company, and based off of my history, the plan was to become an academic professor, right? So I would work at a academic hospital, and I would like see patients once a week, and then have my own research lab where we develop bionic limbs, right? But it was actually while I was doing my PhD that we got the chance to, Brent, as you mentioned correctly, work with the Range of Motion project in Quito, Ecuador. And the co-founder and CEO of the Range of Motion project, David Krupa, is actually an alum from the University of Illinois as well. And so that's how we got connected. And we actually had the opportunity to go down to Quito, Ecuador, sponsored by the US Embassy there in 2014, and work with a patient there. And the patient that we ended up working with, Juan Suquillo, he had lost his left hand 35 years prior due to machine gun fire from a helicopter. He was in the Ecuadorian army, and there was a border war between Ecuador and Peru. And this is a part of a much longer story of 2 weeks of all-nighters trying to get this hand to work. And you have to imagine that the hand that we had built at the time, right, was fully 3D printed. It was 3 times the size of an average adult human hand, had wires going everywhere, plugged into breadboards, plugged into power supplies, the wall, you name it, right? And despite that, Juan, in front of international news stations, said he felt as though a part of him had come back. And that was because he made a pinch with his left hand for the first time in 35 years. And for him to be able to do that and say that in front of these international news stations, that's when I realized that if I just stay in academia, then this just ends up as a journal paper or a university project, and that's the end of it. And if we want everyone to feel the same way that Juan did, we had to commercialize the technology. And that's when Psionic was born.
Okay, and what's the idea? Because you guys are basically working. Well, first off, there's this sensation of touch, right? That's the problem of trying to get the pressure right and trying to get these fingers, for example, at the right place. And then there's also like feedback, and you guys are working on both those things, right?
Exactly. And so we developed the ability hand over the last 7 years or so. So once Psionic was created, and it's available nationwide ever since September of 2021, and it's a fully multi-articulated hand. So what we mean by that is that you can move, all the individual fingers on the hand can move. So there's 6 different movements. So all 5 fingers flex and extend, and the thumb rotates as well. And it's the fastest bionic hand on the market. So the fingers close in about 200 milliseconds, which, to put in context, is actually faster than we blink our own eyes, which is around 300 milliseconds, which is a cool statistic. But it's also one of the first to have touch feedback on it. So if you touch there's 6 touch sensors that we have on the index finger, the pinky, and then the thumb. So it's on the fingertip, the finger pad, 2 on the outside of the end of the finger, and 2 on the inside of the end of the finger. And when you touch it, we can vibrate a vibration motor that is placed in the socket of the residual limb. And it'll vibrate on contact for like about half a second. And then when you let go for about half a second, and then depending on how hard or how much pressure was applied, there's a proportional amount of vibration that the user would end up feeling.
Okay, and why is that important? Does that let me make more precise, like grab things more precisely? Does it make the limb feel more my own? What's the why? Because it seems like a lot of effort, a lot of extra effort. So why is it so important?
Exactly. And so it allows you to manipulate really delicate objects. So we had, in one of our first tests of our haptic feedback system, we had a triple amputee who had sepsis, who was about 80 years old, grab a hollow eggshell on his first try without cracking it while blindfolded because of the touch feedback and that he had and in the hand itself. And our very first user in the US, he is Sergeant Garrett Anderson. He was a retired Army sergeant who lost his hand in Iraq in 2005 due to a roadside bomb. And he typically used a hook on a daily basis, right? And so there's a body-powered hook in particular. And one of the things is that for him was that when he was first fitted with a myoelectric after he got back from Iraq, he tried like holding his grandmother's hand and he ended up almost crushing it because he couldn't detect how much pressure that he was applying on the fingers. And so with our hand, he said that, he's been able to hold his daughter's hand and like actually know with how much pressure he's holding it. And that's something that he wasn't able to do with other prostheses available on the market. Now, in terms of, giving it more of a sensation of your own, that's some of the stuff that we're getting into more recently. So we're partnering with institutions, like I was mentioning, doing brain implants and doing peripheral nerve implants. And by stimulating the neurons and the nerves directly, you can make it feel like the sensation is coming from your phantom limb, right? So that's coming from an anatomically correct location. So if you touch our index finger, it'll feel like it's coming from your index finger that you don't have. And so with that will give the user a more sense of agency, right? Like that this hand is actually part of their own body and an extension of it, as opposed to just being a tool that's attached to the end of their limb.
Okay, but I'm looking at this and I'm like, it looks expensive.
And so, yeah, and when we started designing the hand, we kept that in mind from the beginning. And so when we talked with all the clinicians, and they were saying that if you can design a hand that's more robust than any of the other hands that are on the market, but also have it covered by Medicare, which is typically the gold standard, and if Medicare covers it, then usually other insurance companies will follow suit, then we've got something that will be really special. And so that was our design goal in mind. And so when we bill for when we suggest clinicians to bill for the hand in particular, we tell them to only use standard L codes that are covered by Medicare. And we've actually had Medicare successfully cover our hand, as well as a bunch of the other insurance companies, including Blue Cross Blue Shield and TriNet and the VA and workers' comp and just the whole gamut. And to put things in context, for most high-end multi-articulated hands, only about 10% of the patient population could actually afford it. And that was either if you were in the military and had VA coverage, or if you had a workplace accident and had workers' comp coverage, and that was only about 10% of the market. By getting it covered under Medicare, we've expanded that access to now 75% of patients in the US can afford an advanced bionic hand, and that's what we're really excited about. And that's what Psionic's all about, developing the most advanced bionic limbs, but making them more accessible than ever.
So tell me a little bit about your journey with getting codes or getting it covered. I mean, I know that there's a bunch of different ways that you can go, but it sounds like this journey on getting it covered by Medicare and that sort of thing. What did that look like?
Yeah, the primary thing was to hit a price point that Medicare would actually cover, right? And so by hitting a price point that really limits the features and the kind of engineering that you can put into the hand, right? We can't necessarily custom machine everything and use really expensive injection molded parts that would be cost prohibitive, because that would drive the price up to a price point that Medicare wouldn't cover actually, right? And in thinking in that way, we kind of had to think outside of the box, and how could we make our hand have all these features that we wanted, like touch feedback, robustness, the speed, but also make it at this low cost price point that was affordable. And we were originally 3D printing the hand, as I had mentioned, like completely 3D printing it. But when we talked with patients and clinicians, the number one thing that they had complained about was that their super expensive $50,000 bionic hands were breaking, not because they were doing anything crazy, but they would accidentally hit their hand against the side of a table. But because their joints were made out of rigid injection molded parts, they would end up snapping at those joints. But our own fingers, right, there are a natural finger, if you hit it, right, it flexes out of the way. It has compliance. And that's when we started to look towards the soft robotics research in particular. And so instead of 3D printing the fingers themselves, what we would do is we would 3D print molds and have a 3D printed flexible bone that we would put inside the mold and then inject it with silicone. And that way, the fingers would end up being flexible and compliant in a much more natural way, akin to what a natural finger does. And in that way, we've like smashed our fingers with a hammer. We've like done flaming board breaking with it. I've climbed to the roof of my house, dropped it 30 feet in the air, and it survived that. I put it in a dryer for 10 minutes and survived tumbling around in a dryer. These hands can take a beating, right? But we can still manufacture them at low cost because we'll 3D print the parts, but then we'll reinforce them with like silicone or carbon fiber. For example, our palms are 3D printed, but then we'll reinforce that with carbon fiber and it's strong enough that I can stand on it. So it was kind of thinking outside of the box in that way that we could reduce our costs, but still make it high quality and have all these features that were novel to bionic limbs.
Yeah. And how does it then, because this is a production process, I think it's interesting because soft robotics so far, I've always said it's like kind of an industry waiting for an application because there aren't a lot of actual soft robotics applications. So it's nice that you guys took something from that and made it like a useful thing. But it looks like still that's a very manual production process, right? To do that, right?
Yeah, and one of the things we actually pride ourselves on is that we do all of the production in house. So from all the 3D printing to all the carbon fiber manufacturing to the silicone molding to like the assembly itself. But because of that as well, we've been able to make some innovations in the manufacturing processes themselves too. And so we figured out ways that we can scale this. And so we just moved to San Diego like about 4 months ago. We were located in Champaign, Illinois, where the University of Illinois is for the last 7 years. And one of the big things that we're doing now is we're scaling because our biggest issue is that we've got more demand than we can produce, which is a good problem to have. And so in a lot of the processes that we've developed in doing like the carbon fiber layups, the 3D printing and the silicone molding, we figured out ways that we can actually scale that and so that we can start producing these at higher volumes that are more conducive to meeting the demands on both the prosthetics and the robotic side actually over the next couple of years.
And production in-house, is that something you feel you're doing because you're building a complex device, so you need everything to work together? Or is it, being vertically integrated allow you to reduce costs? What's the advantage here?
It's actually both of those things, but I would also add that having repair and support in-house too is a huge advantage as well, because a lot of patients with a lot of the market itself is in the United States, and so for them to just have to ship something back to the US if the hand needs fixing, then that is very beneficial to our clinicians and patients as opposed to having to do things overseas.
I think it's pretty interesting, and just kind of curious on the data that you guys have harvested, if you're willing to share. The upper extremity side of prosthetics has been kind of vague, I guess, for so long, right? There's all these numbers out there that if you don't get somebody in young, they're going to reject their prosthesis. And so you're really dealing with a percentage of people that you potentially can reach. What are you finding now with 3D printing and some of this technology of who is your market and who potentially can benefit from this technology as far as number and population size?
Yeah, it's really interesting because we have children that are as young as 10 years old all the way to people who are 80 who have received our hand and everywhere in between, both male and female. And we thought that these would be primarily for people with traumatic amputations in particular, right? Because you've lost a hand, you have the muscles to control it, you still have like this notion of or image of a hand that is still there, your phantom limb in particular. And with a lot of congenital or people with congenital limb differences, they usually grow up without using a prosthesis at all, and it doesn't slow them down and they can do everything with like one hand usually, right? But we actually have a lot of congenital users, and what we've found is that usually when they're hitting their like 30s or 40s, they have overuse injuries on their sound side, right? And And so they'll usually have like carpal tunnel or like contralateral shoulder injuries in particular. And that's when they start looking into getting a prosthesis because, they've used their hand for about twice as much as you would a natural, or like having two hands growing up. And that was something that was kind of unexpected for us, that we didn't realize that we would have such a large base of congenital users too. And, one of the things that you'd mentioned too with the advent of things like 3D printing is that we're not necessarily relegated anymore to making the hand look like a natural hand, right? And to put this in context, right, when we went down to, one of the last times we went down to Ecuador was back in 2018, and we were visiting Juan again, and we brought down two versions of the hand. And one was our black carbon fiber look that we have, as well as one that we had matched his skin tone with. So we dyed the silicone to match his skin tone, and we also put like a vinyl wrap around the palms to match his skin tone as well. And our assumption was that he would actually prefer the skin tone matching look, in particular because he had like a myoelectric prosthesis before that he was using that matched his skin tone in particular. And to our surprise, he actually preferred the bionic look. And his reasoning was that when he went down the street, he felt like RoboCop when he wore this bionic hand that had this black carbon fiber on it. And for him, it changes the narrative. It gives him ownership over that narrative that, when he goes down the street with his prosthetic limb that looks natural, that people's default reaction is one of pity, right? They see him and then it's like they're either like, kind of afraid, or they're like, oh, I'm sorry you lost your hand. But when he goes down the street with a bionic hand, it gives him like, it completely flips the script, and people are like, oh my goodness, you have a bionic hand, that's so cool, right? And it gives him ownership over that narrative that this is not something to be pitied, it's something to be celebrated, right? That he was, in his nation, he was a war hero. And because of that, we've seen this like kind of demographic shift towards like these kind of more cool like bionic looks. So, for example, Open Bionics really paved the way for a lot of that cool looking prosthesis that people can customize and have like a sense of pride over as well. So, in terms of those demographics in particular, we're seeing people from all walks of life and all ages actually embracing these bionic limbs in particular, and more so than ever because we can hit a price point that more insurance companies are willing to bill for.
Yeah, I think actually on the coolness, I think Scott Summit was the first, in my mind at least, like to really have these fairings. There was like fairings that were just like really amazing looking. And I think that to me was the first time I noticed. That was much earlier. I think that we could make these things look really cool. And to me, that's and we see that as well in kids. We saw that with Enable as well with kids. That a lot of kids are like, it's the first thing in the process they get to take ownership of. What color is it? So even just like these simple customizations, these simple choices, things just make them feel a little bit more that they're maybe not in the driving seat, but not like locked in the trunk, and this kind of process that goes on without them, right?
Absolutely.
And I'm curious always with the production thing. I mean, I think so. If you're inventing this thing, I'm guessing you guys like started using desktop printers first, right? Or
Oh yeah, and actually we still use like Prusa printers as well for a lot of the components in the hand, and then we also use SLA Form 3 printers from Form Labs as well to do a lot of the more the components that are in the internals that need a bit more resolution in particular.
and why was the decision? Because like other people would assume that at one point you're either going to outsource, right, to a service, or you're going to get like bigger machines or something like that. Does the performance just there for you? And you're like, why not? Or is the iteration cycle quicker enough? Or, why is in-house still a good idea for you guys?
Yeah, so it's because our we can actually hit the volumes that we want with just more equipment in house, and we've and like I was mentioning, right, we kind of specialize the manufacturing processes in particular so that we can actually start to build at scale using these lower cost printers and in-house things that we can actually build these out in-house, and we like being vertically integrated, right? It gives us the flexibility to more rapidly make design changes when we need to, and like strengthen things when we want to. And one of the things that is really nice is that we're able to address things that come up like in the like from our patients rather quickly, right? So for example, one of the things that we've been doing lately is that we've been making a hybrid metal, like 3D printed, like thumb, for example, like a thumb joint in particular. And so our thumb is one of the weakest points of the hand, for example, right? So it can take about 30 pounds of force before it ends up breaking, right? Which is actually more than a natural hand. It's just that you can feel that joint a little bit better in your natural hand than you would in a bionic hand in particular. And you've got more wrist movement in a natural hand as well, so you can redirect the forces so they're not going over the thumb in particular, right? And by combining like this, this hybrid metal, like 3D printing manufacturing technique that we've been developing, we should be able to like support like your body weight on that thumb now, or at least a lot more than 30 pounds that we had before. And because we're doing a lot of the design and the manufacturing in-house, we can rapidly iterate on that and then bring it into the manufacturing cycle in a way that would not be as easily doable if we were outsourcing the entire operation in particular. But that's just one example of why we like keeping everything in-house.
Okay, and are you using like a Mark Forge kind of bound metal kind of process for that, or what are you using to do that?
No, so for example, we'll use our form printer with like a tough resin, for example, the Formlabs printer, and then we will have a separate water jet cutting process for the metal pieces in particular, and then we can just bend them into place and kind of mix the two items together. So it's not actually using like a metal powder or like a laser sintering process for the metal, but rather just traditional like subtractive manufacturing for the metal components.
Okay, that's kind of interesting. And are you looking at like, well, for example, are you looking at sintering or MJF or other technologies, or you just think, no, as long as I can do it in house, that is the most important thing for me?
We have been actually looking into bus print to just because SLS printing has some advantages in how you can kind of stack the components together, and you can make a lot more of them at once as opposed to something like SLA, for example. And so Formlabs, for example, has a new SLS printer that we're starting to evaluate, the Fuse 1, to see if we can actually use that to make much more of the components for the hand at scale than we were able to do before, and in a way that's not necessarily cost prohibitive and can actually reduce our costs because we can make them at a higher volume, but still at a volume that is conducive for these markets as opposed to like iPhone volumes or something like that, right?
And how is that? If you, what's your workflow on the software side? I mean, what kind of software do you guys use for design, and how does that work?
Yeah, so we primarily use SolidWorks in particular for doing all of the CAD design. And then I'm trying to think of some of the other things. We've used Fusion 360 a bit as well, especially when we're doing machining stuff in particular. And then on the electronic side, we use Altium for doing all of our what do you call it? The PCB design, the printed circuit board designs for the electronics that go in the hand.
Aadeel, I'm just kind of curious. It's always interesting dealing with, you've got a component, so your hand side of things, but then obviously you've got to interface some way and somebody that's providing the prosthesis and such. Tell me a little bit about what you've learned along the way about socket design. Is it important? And then I'd love for you to dive in a little bit into, I know you said you guys are, kind of open to control systems and electrical or sensors. But I was just wondering, is there a combination that you're seeing, just knocks it out of the park?
Yeah, absolutely. So with respect to the sockets, they're actually one of the most important things because you can have the most advanced hand in the world, but if the socket is not comfortable, then it is not going, no one's going to wear it. And so when we first started, when we actually went down on that Ecuador trip back in 2014, we were actually looking into 3D printing sockets as well, where we took a scan of the residual limb. And there were a couple of reasons why we personally did not go in that direction in particular. And one was that at the time, at least, the 3D printed socket that we had made for Juan, it wasn't necessarily comfortable. And with there were other companies that have been taking this approach too, where they would scan the limb. So like Unlimited Tomorrow and Open Bionics, for example, have been taking that approach. And we wanted to work with the prosthetists because we knew that they had years of experience in in developing sockets that were comfortable for patients in particular, as well as their experience with working with the insurance companies to bill properly for these sockets in particular. And the other thing was that we knew that research-wise that on the horizon was going to be osseointegration in particular. And we actually have several patients now who have osseointegrated implants that they got either at Walter Reed or Johns Hopkins or some even in San Diego here through the military hospital. And for that reason, we kind of decided to focus on the hand, and because eventually we see osseointegration really becoming a standard of care over the next like 5 to 10 years in particular. And so that was actually one of the big reasons why we moved to San Diego as well, was to work with the military hospital on some of these newer technologies of like osseointegration directly into like your humerus. So if you're an above elbow amputee, or to like your radius and ulna if you're a below elbow amputee. And what I would say is kind of like the holy grail of this stuff would be to combine a peripheral nerve implant in particular with the osseointegrated implant. And that's one of the things that we're working on with our partners at Nerves Incorporated in Dallas, as well as the Navy Hospital here in San Diego, is combining the osseointegrated implant with these direct nerve implants that are in your arm that you can do individual finger control with, that you can touch the fingers and stimulate your nerves so it actually feels like it's coming from your hand. But even more importantly, when the fingers move on the bionic hand, that we can stimulate your proprioceptors in your nerves to make it actually feel like your phantom fingers are moving as well. And that really completes that illusion that you can feel from it. You can detect when it's moving with proprioception, and then also you can actually control those individual finger movements. So it's going to be a really exciting future that we're going to be having in the next 5 years.
And if you're looking at this, I mean, if you are looking ahead, I mean, you have to, of course, you've balanced already this kind of thing, like, okay, we want to make the most advanced and possible, but we need to keep it in the bandwidth that it's affordable for Medicare and other systems. And how are you going to like get the next big group? You know, what's needed on your side to scale it up to get the next 10,000 people or whatever?
Yeah, and honestly, the biggest thing is that we just need more people and more equipment. And because of that, we're actually doing a seed round. We're raising our seed round right now on Start Engine. And so it's an equity crowdfunding campaign in particular to really scale up the manufacturing. And, you know, one of the things that we realized too by doing an equity crowdfunding campaign is that on the product side, we're all about accessibility, right? Like making the hand more accessible than ever. And so we were like, why don't we also make the company accessible to people as well, right? And the coolest thing is that we've actually had many of our users actually invest in the company. I'm like, this is exactly why we wanted to do this, right? We are building these devices for them, and they get to be a part now of the journey of the process of building these devices and a part of the company. And so we're really excited to have, you know, as many of the people in the community as possible be a part of PSYONIC and just really bring it to the next level of what's going to be like, you know, get these out to the masses.
Okay, I'm interested in this Start Engine stuff, because I've been seeing it a little bit more lately. So essentially, how does it work? I mean, well, first of all, why did you decide to do it? I mean, you know, you could have tried to hit up like VCs or other types of investors. Why did you end up going with this Start Engine thing?
Yeah, and you know, going the traditional VC route, it limits the people that you can have on board, right? So one of them was like we wanted to have like our users come on board, right? Like that they get to own a piece of the company, and especially like people like military veterans in particular, right? Like our first user in the U.S. was as a military veteran, right? Sergeant Garrett Anderson. And a lot of times they don't get the opportunity to invest in companies like this that are being developed for them, right? So that was one of the reasons. Another one was a lot of our sales actually come through social media in particular. And for a medical device company, that's actually not common. It's usually having sales reps that go out to the clinics themselves and sell that way. But for us, I mean, we've been demonstrating things that is not typical that hands can do, right? Like flaming board breaking or bottle flip tricks, or like, you know, dropping it from the roof of my house. Or I arm wrestled against the para triathlete national champion who was using our hand and I lost, right? And by showing that, these hands can handle these like crazy activities, right? It can handle the forces of arm wrestling. It can withstand like, punching through like wooden boards. It has the dexterity and the flexibility to do like bottle flip tricks. It gathers a lot of interest from the limb different community. It's like, oh wow, I didn't know that hands could actually do things like this, right? And so by doing a crowdfunding campaign, it's also kind of expanding the reach of our content so more users can see this, and then they can be aware that, hey, that they can get a prosthetic hand like this too. And then finally, the other thing I wanted to mention too is that, with the economy the way it is right now too, that the VC market is not necessarily in the best option to go for funding right now. So it's kind of like all of those aspects combine on why we decided to go with a crowdfunding campaign. And we've already raised more than $650,000, and it's been like a little bit over a month since we started. So we're really excited to have all these people on board and really take our hand to the next level, like I was mentioning.
Yeah, cool. So what I like, I'm looking at this right now. So this price for share at the moment, 235. You got a pre-money valuation of nearly just shy of 50 mil. And essentially you're saying that your maximum offering is 1.2 million, right? And the minimum investment is $249.10. So that's making this really, really accessible to a lot of people, right?
Exactly.
What's the due diligence on this? Is it like you just sign up and they're like, yeah, let's go with this? Or because we are really reaching like super retail investors now. I mean, with VCs, hey, we're all big guys in the room. Somebody gets hurt, no big deal. But now we're talking about very risky asset class, which is startups, and then and just retail investors. I mean, is there a lot of due diligence, or is it surprisingly easy to do this?
So, I mean, we had to, put together the entire Form C offering for the SEC and go through like the gamut of like legal things, right, to make sure that everything that we were saying was not unfounded, right, including things like the valuation and everything like that. So there was quite a bit of due diligence on that, and the thing is, a lot of our previous investors who were angel, so we raised a round before this through angel investors and VCs, and many of them have come on board for this round as well. So that further just validates that this is like legit, right? It's not that everything is being backed properly, and one of the reasons why the minimum investment amount is $250 is because that way a lot of, like you said, retail investors aren't breaking the bank and actually going in on something that they might believe in, right? That they've wanted to invest in for a very long time. And, I've gotten many, many messages from a lot of investors in this new round that, they're like, I have been waiting years for this opportunity to finally invest in you guys. But, it was always like cost prohibitive before because, you needed to write like $25,000 checks before. And so they're so excited to have this opportunity to be involved with the company in a way that just they didn't realize that would be possible unless we went like public, for example, right?
And do you have any tips for other people doing this? Because I can imagine that people would be curious about this. I mean, because do you need like a ton of attention? You mentioned you had a following on social media. If I just showed up and said, "Hey, I've got a cool bionic hand," I'm guessing no one would invest, right? I really need that presence, right?
Yeah, and a lot of it will go into the marketing in particular, right? So and we, like for Halloween, we had like a video where we can actually program the hand to walk on its own, like Addams Family style, right? And so we had this video on Halloween where that we had an army of ability hands just like web me up in our new offices. And then on the robotics side too, so a lot of robotics researchers have been purchasing our hand, including like Meta, like Facebook, as well as and NASA. They're putting it on like a humanoid astronaut. And we actually put the hands on a Boston Dynamics Spot dog, the robotic dog that can dance. And then we gave it some lightsabers, and I had a lightsaber duel against it, right? And so we have these like fun videos that show off like the capabilities of what our hand can do, but we do them in very like novel ways, right? So because we were making those videos even before like we even thought about doing a crowdfunding campaign in particular. So it just kind of worked out that it was like, all right, like we can just use a lot of that content that we've been having fun making anyway to use for our Start Engine campaign in particular. So a lot of it will come to the marketing of the products themselves too, and getting that attention, because you need to get the word out to as many people as possible, which is kind of a different strategy from going the VC route, right? Which is where you need to get like introductions and then like do like a pitch like in front of like those people, and we've done both, right? And each side has its pros and its cons, but for now I think we're we're really excited about having, this new community on board that just never had this opportunity before.
And what is the path to market? I mean, okay, so you get a lot of people. Somebody sees this and think, "Oh, wait, maybe I'm a candidate for this." Maybe, like, how do they get in touch with you? How does it work?
Exactly. So they'll usually shoot us an email, and if they have a prosthetist that they're already working with, then we will contact their prosthetist and work with them and then go through their insurance that way. But if they do not have a prosthetist, then we'll usually find one for them in their area in particular, and then we'll do the same process where we work with their prosthetist to make sure that the hand is fitting properly, that everything is working well, and then that they'd be able to get it covered as well. So yeah, and again, that's not the typical way for the prosthetics companies or just medical devices in general to work, but it's been working pretty well for us.
And with those raise, right? I mean, what do you hope to do with the money? Just expand production capacity, develop a new arm? What are you trying to do?
Yeah, so the biggest thing is to scale our manufacturing. So, like I said, our biggest issue is that we've got more demand than we can produce. So, an exciting problem to have, but also to start R&D on the new stuff. So, we've got a 5-year goal of making an ability leg that you can do a triathlon in. And it's another reason why we moved to San Diego, because the Challenged Athletes Foundation is headquartered like 10 minutes from us, and they hold the para triathlon every year, for example, as well as, some of these like osseointegration plus nerve implant research that we're working on in particular to just bring this, the control and the feedback to like the next level for both arms and legs. So both on the R&D and the scaling side, we're really excited to be working on that.
And why are you making a leg? Because it seems like there's just so many people out there that could benefit from like a better arm, that would offer you like a lot of opportunities to work in that space.
Yeah, and so the thing is, a lot of the technology that we developed in the hand is actually applicable to knees and ankles as well. And a lot of our patients actually have sepsis or had sepsis. And so they have multiple limb loss, right? So some are like missing a leg and a hand, or like both legs and a hand, or like all 4 limbs in particular. And having that all under, like the same system working together, I think that can be really beneficial for a lot of our patients in particular. And so that's one of the reasons why we wanted to work in both upper and lower limb in particular.
Okay, that sounds like super exciting. I love what you guys are doing, bringing this technology there and stuff. And yeah, I think it's a really exciting path forward, let's say. And yeah, thank you so much for being here today.
Yeah, it was my pleasure. This was really fun.
Yeah, thanks. And Brent, thank you as well for being here as always.
Oh yeah, this was great. And Aadeel, thank you for sharing your story and vision and such. I think our listeners will really enjoy it.
Thank you, guys.
Hey, thanks a lot. And thank you guys for listening. This is another Prosthetics and Orthotics podcast. And have a great day.